One moment. Yeah. Now we hear you and we see you.
Perfect. Thank you very, very much. And please let me know if you can see my screen. I'm just going to. Is that also visible for everybody?
Yes, we see your screen. Everything fine. You can start.
All right, thank you very much. So my name is Omar Haqqi, and I recently joined the team here with UMDIS. I feel very privileged and very honored to be in company of such amazing people and to be able to present to everybody here. I have 25 years of mixed, let's say, experience in mushroom cultivation, mushroom composting, in a large, let's say, variation of circumstances in the Middle East, in the Arabian Gulf, in Asia, and most recently in Europe. I've also done a few visits here and there to South Africa. So I've been privileged to have been able to see a lot of different situations, different farms, different levels of farms across a range of climate zones. My big passion really is for spreading knowledge. I love to, I love sharing my knowledge, I love sharing experiences, and I love seeing solutions to difficult situations. And I think mushroom growing is all about that. It's all about sharing knowledge, and it's really all about solving those unsolvable problems, because I don't think that there's any problem that cannot be solved. The other thing that I strongly believe in is that mushroom growing is about people. Yes, it's a business. Yes, we're all here to make money out of mushroom growing, but it's also a lot about people. There are so many people involved at all the levels of mushroom growing, starting from the investors to the people who work there, who commit their lives to this wonderful industry of ours. The subject I'd like to draw attention to is, in my opinion, sometimes overlooked and sometimes underestimated. The subject here is about the role of the ambient temperature and how it affects mushroom compost quality. Of course, this is not to say that this is not studied or that there isn't any data or there isn't any literature on the subject. There is, but from experience, I feel that a lot of the farms, the growers, the compost makers, in some instances, they might not give it the attention that it deserves. And so here I'm going to try and highlight this aspect of mushroom growing. So obviously everybody knows what mushroom compost is, but we all can agree that mushroom compost has three big, say, areas that we need to concentrate on. The first one is the physical characteristics, which we all understand. The mushroom compost needs to be of a certain texture. It has to hold moisture. It's where the mycelium is going to grow, so it needs to have the right pH. All of these things. It shouldn't be over-composted or under-composted, greasy. All these aspects. The other aspect is, of course, the chemical composition. You need the right nitrogen at the end of phase 2. You need the right pH. Now, although the pH can vary, obviously, but you also need the right CN ratio, which is more critical, and you need that compost to be free of gaseous and liquid ammonia. So hopefully you've cleared by the end of phase 2 your gaseous ammonia, but you also have very low NH4+. But there is a third aspect of compost, which is life. Compost is a living, it's a living ecosystem. It's not just the physical and the chemical. The aspect that I would like to draw your attention to is the fact that there are a lot of things that are alive inside the compost, and these are very important. They are important during phase 1, at the end of phase 1. They are very important during phase 2, and they need to be present in enough numbers at the end of your phase 2 so that you can get a good compost. Now, the objective here is to demonstrate how ambient temperatures define compost quality. What is the relationship? Why is it that, say, I can perform a procedure in Europe with the same amount of straw, the same amount of chicken manure, and then I take that same procedure, the same condition, the same formula, let's say, similar types of straw, and I do that exercise in Asia, in a place where the ambient temperatures are much warmer, much higher, and then I don't see similar results. I see different behavior. I see different ammonia levels in the tunnels, and then I see differences in quality and yield. So this is what I'm trying to kind of highlight here. And if we understand this area of composting, I think a lot of us here, a lot of you there practicing compost will come up with something beneficial to them. Stable, high quality compost matters. We can all agree on that. It helps you predict consistent yields. It helps you with your mushroom quality, with your mushroom shelf life. It helps you match your flushes to your market needs. I could go on. This is just, I'm just scratching the surface. These are just a few of the points that are important. There are dozens and dozens of points. I could just go on, I can talk for an hour. I wouldn't even cover everything. But it's important that when you have high quality mushroom compost, it's not just yield, it's the quality of the mushrooms themselves. The shelf life improves. When you don't have a good quality of compost, you get low quality mushrooms. They may open too soon, they may brown, your shelf life is bad, your market performance is bad. So a good high quality selective compost is important for this. And I cannot stress how important it is. And of course, the big one, yields. If you don't have a high quality compost, if you don't have a selective compost, your yields are going to suffer, and you could be averaging low yields for many years. You might not even know why this is happening. You're following everything by the book, but if you're not paying attention to the compost biology and the effect that this has on your yields, you may never you may never uncover the secret, let's call it. I think a lot of us will probably recognize this diagram or the sketch. Some of you may have seen it in the older books, the old Van Greensvan book, or maybe the Paul Stamets book, and maybe some of the more recent ones. This is just a version of it, and this is just to explain the chimney effect in compost. Here we see the direct connection between ambient temperature and the temperature of the core, or the core of the stack. This is obviously just a traditional old style compost stack. It's not a bunker or a tunnel, but here you see the direct relationship. There's something called delta T, and delta T is the difference between ambient and your compost. And the bigger the delta T, the better your air movement. Your air movement is directly affected by how big a difference there is between the outside and the inside. So when you have cool air outside, you get better air movement, and when you have warmer air outside, you get slower air movement. Higher air movement or better air movement gives you a more oxygenated stack. It gives you less anaerobic spots in your compost, but it also gives you some nice survival zones on the edges. So all of these things work better in a cooler climate, and they work to a less extent in a warmer climate. So imagine you're doing compost in Europe, and it's to, let's say, 4 degrees outside, as opposed to doing the same compost even in European summer, say when it's 25, or you're somewhere in Asia where it's 35 and 40. The air movement just isn't going to be the same. And that air movement affects everything from the quality of the compost, but most importantly, to what is living and surviving in that compost. To a certain extent now, phase 1 bunkers do, or let's say they are affected by ambient temperature, although much less to the extent that we see in open rick composting. There is a chimney effect that happens in bunker composting even when the fans are off. We see it, we can visibly see that. It's less important, obviously, than in a stack. And you are also looking at survival zones within phase 1 bunkers. So in a cool climate, you may get more survival on the top, you may get more survival near the walls, or even sometimes near the floor. And these little survival zones, they help re-inoculate your compost at the end of phase 1 going into the phase 2. It's not the best method, but it's part of what helps your compost survive during phase 2 and flourish during phase 2. And to a large extent, phase 1 tunnels are less affected by ambient. That is because everything is controlled. The air that is going in is certainly, it is taken from the ambient, and the cooler it is, the better. But because the conditions are more controlled in the phase 1 tunnels, and the air movement is usually continuous. That is not to say that they are not affected by ambient, but it's obviously much, much less important than your outdoor compost or than your phase 1 bunkers. So we've come to the big one, the important one. How do we keep the compost alive? How do we keep the compost alive, let's say, at the end of phase 1, going into your phase 2? Because remember, Most of the time, when you're performing phase one at very high temperatures, when you're hitting above 80 or even above 75, above 80 in bunkers or above 75 in tunnels, you're pretty much killing all the beneficials. There's nothing that's going to survive. So we need to ensure there is survival, and we need to ensure that your compost is re-inoculated. This is the point that sometimes people underestimate. I'm not going to say neglect, because the big tunnel companies, they realize this. But it's sometimes underestimated, especially with individual compost makers. You've reached the end of phase one. Your compost is nice. It's black. Your nitrogen lignin humus complex is good. It's bouncy. It's black. It's holding the right amount of moisture. Your nitrogen is good. Your ammonia is good. But you need to reintroduce life. You cannot just take a sterile compost and throw it in the phase two tunnel. You have to make sure you have enough inoculation, we'll call it. We have to make sure you have enough yeast or sourdough going into your compost, going into the phase two tunnel, because this is where these beneficials are going to work. This is where they are going to do their action, their magic. It's basically during the conditioning phase. You pasteurize, you're going to get rid of all the harmful things that are in your compost, all the insects, all the, let's say most of the competitor modes, but then you're going to regrow the beneficials, and you regrow the beneficials during conditioning in those 45, 46, up to 48 degrees. But if you don't have beneficials to start with, nothing will grow in your phase two. And this is the point I'm trying to draw your attention to once again. So what are my top tips for keeping your compost biologically active before phase two? In a warm climate, I would usually look to moderate moisture. I would usually try to keep the compost slightly on the drier side because it helps with air movement. You can always correct a slightly drier compost, but it's more difficult to correct a very moist compost. A very moist compost, there's not much you can do with it except, empty the bunker, refill it again, maybe flip a few times. But with a dry compost, you can always make those amendments. A slightly drier compost, and I'm not talking about excessively drier, but on the drier range gives you better air movement, better performance. My other tip is in warm weather climates, I have found, and this is anecdotal, I have found that when I formulate at a lower range of nitrogen, I get better results. This is not to say that you're going to get bad nitrogen at the end of phase two, or it is not to say that nitrogen is the most essential thing. Remember, you're looking at the end of phase two, you're looking at your CN ratio rather than your total nitrogen. And mushrooms really don't take up a lot of elemental nitrogen from your compost, even at the end of the growing period. But lower nitrogen is helpful in keeping the compost light, because lower nitrogen means less dense compost. Less dense compost, improved air movement, better overall for your microflora. And also easier to clear the ammonia if you're having difficulty doing that. My third and most important tip, boost your microflora. There's many ways of doing it. In a phase two tunnel, in a phase one tunnel, the big companies, they sprinkle a little bit of phase two compost on the phase one going to the phase two. Sometimes I was discussing this with Maksym the other day. In phase one bunkers, people just put on the fan, the day before filling into your phase twos. That helps. That can work. Obviously, if you're in a cool weather climate, that works. But if you're in a hot weather climate, it might not be the best method. But boosting your microflora has to be done. There is no one single magic bullet for it. There's many different methods. We can discuss this later further in detail, perhaps during the course or in a one-on-one session. But be sure that it has to be done to ensure good quality compost and to ensure those high yields. And it might be the answer to some of your problems. Not all of them, but certainly some of them. Just a few notes on the differences between winter and summer composting. Remember, we mentioned in summer the airflow is more shallow. You get more drying on the outside. It's you suffer from slower cooling, particularly when you're trying to cool down your phase two tunnel. Whereas in winter, the convection is better, the oxygenation of your compost is better, and the moisture retention is usually better. And more on these two and differences, let's say, between the summer and the winter. I'd like to draw your attention to an important one which is dewaxing. And this is something that even the big compost makers, find challenging. In summer, it's more challenging to do dewax your straw. That is, get your straw started, get your compost started. And it's for the same reason that we mentioned before. It's the delta T. Higher temperatures means, more difficult air movement through that big stack of straw. Lower temperatures, it's easier to get it started. So in winter, dewaxing is faster when you have a higher delta T. What are my strategies, or let's say if I want to summarize some of the points I was talking about before, go with lower moisture in summer. It's better, easier. You can always amend your moisture. Don't forget to reintroduce your beneficials at the end of phase 1. This is very important. Again, there are many different ways of doing that. We can talk in more detail later. Start with a lower nitrogen formulation. Bear in mind, nitrogen is not directly food. Nitrogen needs to form a nitrogen lignin humus complex with your carbon, but you need a nice CN ratio at the end of phase 2. It's not direct food. This is something that people don't always realize. Also, nitrogen, no matter, if you start with high nitrogen or lower nitrogen, the nitrogen seems to go in a kind of a curve motion. So lower nitrogen always gets you closer to the 2% that you want. Higher nitrogen gets you closer to the 2% as well. But you may have 1.9 if you go with lower nitrogen, and you may have 2.3 with higher nitrogen. It's the same thing. It's not that critical as people sometimes give it credit to. Ammonia is a tricky one. I want to draw your attention to this one because ammonia in warm weather climate phase 2 performance can be tricky. You might not get the same amount of gaseous ammonia as you might in a European setting, let's say. Even if you're following the exact same formula, exact same chicken manure, horse manure, the same let's say you have the same straw, your ammonia will behave differently from one climate to the other. Do not, don't overthink ammonia, but certainly watch your NH4. You need to watch what your NH4 will end up at the end of phase 2. That's a better tool. That's a more indicative tool, in my opinion. So let's say even in more advanced farms, you can have low yields. You can have overheating during phase 1 that is not corrected. You can have overheating during your pasteurization stage. But this one is actually one of the things I found more common in advanced farms. Dewaxing can be tricky. Say, for example, you're a European tunnel company and you're receiving horse manure all year round, and all of a sudden you run short of horse manure and you need to make your compost using straw and chicken manure, or starting with raw straw. And if your dewaxing is not done right, you might end up with a green compost. So always bear in mind, it can happen anywhere, anytime. Compost making principles are the same. The weak chimney effect can also happen even in the European or more advanced setting, let's call it that. Because if you think that 35 or 40 or 50 degrees is a problem, think again. Even 25 degrees can be a problem. My conclusion, it's important to understand that compost quality is not managed by luck. It's managed by understanding ambient temperature and by understanding the relationship between ambient temperature and how that affects the compost breathing rhythm. And if we understand that rhythm, we can have a lot of control over yields. My final call to action is that if you are able to adapt your compost strategy to your climate, you'll get yield stability and you'll get higher yields. And if you understand compost biology better, you're going to get better performance. I'm going to say one blanket statement and one claim, and I'm very happy for you to challenge me on it. I believe each and every one of you, wherever you are, anywhere in the world, you can make amazing compost. All you have to do is have the right tools and have the right understanding. And anyone can do it. Well, not anyone can do it, but I'm sure most of you can. It's more easy when you understand the basic principles, and we're obviously here to help. Thank you very, very much for your attention, and I hope I didn't take too much of your time or bore you too much. I'll hand it over to Maksym now. Maksym, I think your mic might be off. Yeah.
Yeah. Sorry. Thank you, Nir. So thank you, Omar, for perfect presentation. It was very specific, not too long, and I really enjoyed it. I will give you a few minutes to rest before we start our questions session. And please, everyone, please prepare your questions. You can write them to the chat, or I will let you switch microphone and ask questions by voice. And for these few minutes, I will show you a short overview of our composting course, which we recorded last year with my friend Roman Stolper. He's very good expert. He was very good expert in composting. Unfortunately, he passed away a few months ago, and his last work was in Ireland. He worked for Walsh Compost, custom compost in Ireland, and we planned to do hands-on course, a composting course with him there, but it didn't happen. So now we have Omar in the team, we have Makis in the team, and I hope we will have opportunity next year to have composting course hands-on. And if you have your compost yards and you can offer your facilities to show people how to produce compost, please contact me. I will be very happy to conduct courses on your facilities. And now let's see a shortly program of our online course. It has 11 recorded lessons, stage by stage of composting process. Not everything is there, but it can help a lot of composters to achieve a better understanding of this process. We have first lesson about straw as main raw material for the compost, a lesson about chicken manure and other ingredients that used in composting, including gypsum, urea, some supplements, or for horse, also some horse manure for those who uses this. Then we have lesson about main analysis that used in composting formula, how to calculate quantities of ingredients for compost, what you should try to achieve, composting schedule, how to build schedule for your compost yard to produce quantities compost needed. We have overview of compost yard, what you should have on compost yard depending on your situation of your condition, process of mixing, very important, process on in composting, probably the most important. And then about phase 1, phase 2, 2 lessons about phase 2, about equipment for phase 2, and about graphs and how to do phase 2 actually, and phase 3 compost. And also this course contains some recordings of webinars that we conducted. We will add this webinar to this course. So you can buy this course now only for 200 euros. And in addition, for next week, you will have opportunity to speak with Omar for half an hour or even more about your specific situation on your compost yard, and ask him question and discuss your situation with him. For those who are not aware what UMDIS does, I will tell that we do a lot of growing courses. We have online courses, we have offline courses. Next week we have a course on the biggest mushroom farm in United Arab Emirates near Dubai. From Monday we start 4 days growing course with Yuri Boychuk, our consultant in United Arab Emirates. Also we have a course in December in Poland for mushroom, and in December also in Poland for Pleurotus mushrooms. So join our courses. And now we are ready to questions and answer session. Let me allow you to switch on microphones. Yeah, you can now. Please ask your questions.
I think I see a question from Eric there.
Yeah, Nikodem, please, can you switch on microphone? Nikodem?
Yeah. Okay. Now it's. Do you listen to me?
Yes.
You say that we evaluate quality substrate because compost is only part of substrate. How many kilos per square meters in 2 flushes in filling 85 kilos mean good compost?
So thank you for that question. Yes. Are we talking about 85 kilos of
phase 3?
Phase 3. Well, if you're filling 85 kilos of phase 3, you need to be jumping over 30 kilos per square meter on that filling. And if it's a very, very good high quality compost, you should expect to get something in the range of 23, 24 kilo per square meter, say in your first flush, the biggest one, and then perhaps another 7 or 8 kilos per square meter on your second flush. So you need to be jumping the 30 on that. This is of course ideal conditions, nice spread out picking and high quality phase 3. You should be able to do that for sure. This is my experience, at least when working with high quality phase 3 in phase 3 farms.
Sorry, in our situation in Poland, 32 kilos is minimum.
Yeah, absolutely. That's exactly the point. You need to be. Are you talking about 32 kilos in terms of the first and second flush, or on your first flush now?
No. 2 flushes, 20 and 12. It's minimum.
Yeah. Yes, exactly. You could be doing 20 and 12. You could be doing 24 and 7, 8. Depends on how hard you push the first flush. But yes, I completely agree. 32 on a high quality compost is absolutely doable, and it is important for sure, especially for the economies or the economics where you're working with your European situations and your cost of harvesting is high. You do need that amount of mushroom, 100%.
Okay, only my last remarks. The main problem with the compost we can observe on a second flush. Generally, first flush is about 20, relatively good. Then quality is less, then yield is lower, but not by number of mushroom, only by weight of individual mushroom. It's a problem generally, the composition of straw. It's a main problem nowadays. And the Christians proposed last time the tunnel for phase 1 for full control air conditioning. It will be stabilized. If you have no good compost during 3 first days, you never can improve them. You can only decrease quality, but never improve them. It's a key point from my experience. Thank you.
Thank you very much. I agree with your comments 100%. Phase 1, how you carry out your phase 1 is very important, and how it affects everything afterwards. I completely agree with your comments.
Okay.
Thank you very much, Nikodem.
Okay, the last one. I observe how big is influence of fully growing process. Very often people keep in tunnels, for example, in a schedule, 14 days,
Yeah.
but not to the end of fully grow.
Yes.
It must be done. Another time is difficult to characteristic compost than is and fully grow. Thank you.
I agree. 16 days is ideal. Yes, I completely agree with that. 16 days is definitely ideal as opposed to 14. Yeah.
Thank you very much, Nikitin. Juan Antonio, please switch on
Hello, Mark.
microphone.
Hi,
Hello.
hi, Juan.
Hello, Mark. Hello, Maksym. Thank you for the free webinar. That is very interesting. I want to know, because I have a mushroom farm here in Peru, and I am having a trouble in dead compost. I think it's in the stage 2 bunker that I have very high temperatures. I'm achieving approx 86 degrees in bunker, and I'm having trouble later in the salas. So I want to know how much temperature I have to achieve in bunker. What's the ideal? I'm having like 9 days in bunker with three stages.
Okay, so I'm not worried about your 86. I'm worried about what happens after. Your 86 is actually a good thing because it means your compost is very highly aerobic and that your composting process happening there is free from anaerobic conditions, and you're chemically burning now in the 86. Above 80, you're actually in your Maillard or the Maillard reaction, which is good. So yes, 86. You're correct to be concerned about the 86 because the 86 is killing all your beneficials. But the question should be, what should you do after, not what you should be doing during. Because for me, 86 degrees means you're having an excellent phase 1. Now, how to fix it after is the big question. So, what is your ambient temperature average? Is it? I imagine it's warm in Peru, but what would be the average? Let's say, or overall.
It's 24 degrees in the outside, and the bunker, I have like in 3 parts I take the temperature, and the center is 86 and the other parts are like 83, 82 degrees.
Okay, I'm gonna give you the easiest tip and a quick one. Okay, when you're taking that compost out of your bunker and you're going to fill your phase 1, you're going to fill your phase 2, keep a little bit of phase 2 compost on the side from the previous tunnel, okay, and remix it with your compost. Remix it with your phase 1 going inside the tunnel. On the moment you are filling your tunnel, your next tunnel, take some phase 2, put it on top of your compost, and then fill your phase 2 tunnel. Usually about 1 to 2% should do it. Okay. Now, if your phase 2 is not heavy with microflora, it may not be enough, but this is the best thing that you can do straight away. Obviously, there's a lot of more things we can talk about in more detail that the time will not permit. But if I'm going to give you one tip, do that. And this applies for everybody. Everybody should mix phase 2 with their phase 2.
Thank you very much. So with that, I will be reintroducing life in compost.
Yeah, you have to, exactly. That is the best way to reintroduce life. You can cool down your bunker, of course, the day before, but the best way to do it, take some phase 2, mix it with your phase 1, fill in your tunnel.
Thank you very much.
Thank you very much. I have a question. We recently discussed cool down before filling phase 2, and what Roman suggested, what he actually did in Walsh Hill, they switched on aeration for a long time before filling and cooled compost to less than 60 or something like this, and filled it straight from bunker to the tunnel. But another expert suggests that we remove part of the compost or all the compost from the bunker to the concrete floor, and after this fill to the tunnel. What is your opinion if about this? If needed to remove compost from the bunker before filling?
Yeah, right. So that's a very good question, a very good observation. I think cooling it down, it works, especially if your ambient is cool. So if you have a nice cool ambient, you're in a cool weather country, cooling it down is effective. It works. Also taking it out on the platform, allowing it to cool, and then putting it into the phase 2 tunnel or taking part of it out is good. But watch out for anaerobic, because if you take out your compost from the phase 1, put it on the platform, it can very quickly go anaerobic. It's not a good idea to keep it more than 3-4 hours, because that's how fast it switches from aerobic to anaerobic. My advice is, if you're going to do that, be fast. Let it cool down, mix a little bit of phase 2, but don't leave it too long on the platform just sitting. The risk of anaerobic is high, and the risk of anaerobic is more harmful than you can possibly imagine. It's really, really very, very bad for your compost. So do it, but do it fast. And yes, certainly cooling down helps. Cooling down the bunker helps. Once more, ambient. If your ambient allows, then that works. But what if you're in a place where it's 45 degrees and 50 degrees outside? Then cooling it down, you're pushing 50-degree air into an 80-degree bunker. It's not going to be as effective. So this is where we have to think a little bit further, how to improve that biology.
Thank you. Does anyone have other questions?
Yeah.
Please.
Thank you very much. Thank you, Maksym. Thank you, Omar. You are doing a great job for beginners and for expertise in mushroom cultivation. Thank you for that. And my question is that in some farmers, they use completely closed bunkers. So is there any advantage of that, or you recommend the partially open one? Thank you.
No, I mean, look, a completely closed bunker or an open bunker means if you're a completely closed bunker, it's a phase 1 tunnel. It becomes more or less a phase 1 tunnel. So all of the let's say the conditions inside that bunker are more controlled. Once again, if you are going to have a completely closed bunker, I would say the survival zones will be smaller. The cooler zones that remain on the bunker or on the surface of the compost or on the sides will be smaller. So you have to always re-inoculate your compost. Now, I just want to ask you a question. Are we talking about a bunker that is working on an on and off type of fan and it's completely closed?
Yes.
So if I understand, yes, it's a bunker that is completely closed, but it's not continuous fan running. It's on off. Is that correct?
Yes, it is.
Okay. My advice: don't close the doors. Leave it open. It's not going to hurt because it's actually going to help you. It's going to help you keep some survival zones, some more improved and better survival zones. Now, if you're achieving 80 degrees plus, I imagine in that bunker, again, re-inoculate. You have to re-inoculate. It's very, very important. I hope that answers some of your
Thank you, Omar. Thank you, Saleh. We had a question from Muhammad. Please switch on microphone and ask.
Yes. Hello, everyone. Can you hear me?
Yes.
Clearly, yes.
Thanks for everything. I have a question for farming stage. My question is about the compost blocks. What is better to me as a farmer, to put the compost with the plastic blocks or free it from the plastic and put it on the shelf immediately?
I think both work. My experience has been with opening it and refilling it, because opening it and refilling it breaks the mycelium. And when you break the mycelium, you're kind of reinvigorating your compost. It's a lot like receiving phase 3 in a truck, that phase 3 is being broken up, and then you're refilling into your rooms. So there's no right or wrong. You can work with closed blocks and keep the plastic on, but if you have the ability to break the compost, loosen it up, and refill it, in my opinion, it's better.
Okay, thank you very much.
Thank you, Omar. Another question from me. In hot climate, when outer layers of compost on phase 1 drying out, should we somehow wet it, put water to not let it go completely dry?
Yeah, that's an excellent question. I faced that a lot. I'm going to be completely honest with you. It's not that important, because the layer you're talking about is extremely small. When you do turnings, it's gone. It's not going to be there. You won't really see it in your end result compost. Also, if you water on that stage, there is a chance you can cause anaerobic conditions. If you overdo it, there's a chance you can cause anaerobic conditions. And watering on a stack or on top of the bunker, usually that water only touches the surface. It's not really going to go inside properly. If it does go through the compost, it goes through channels and it goes all the way to the bottom, and you're not really improving your compost moisture. Yes, you're right. You're getting rid of that dry crust on the outside, but in my experience, that dry crust is insignificant. It's not even 1% of the compost. If you're doing 2 or 3 turnings in your bunker cycle, you won't see it. You won't even feel it or see it or affect it. So I usually skip it, but if I do it, if I have to do it, it's very light. I'm careful. I don't cause anaerobic conditions.
Thank you very much. Any other question in the audience? Eric, please ask. Eric, please ask your question. Saleh, please wait.
Okay, thank you. Thank you. Okay, I understand that using artificial aeration, I mean, substitutes works well even at the high temperature. Is that right?
Can you repeat? Sorry, Saleh. The voice is a little bit unclear. Can you repeat, please?
Thank you, Omar. Yes, I will do. I understand that using artificial aeration, using turbines for injection air, will substitute and work as well even at the high temperature zones. Is that right?
Will substitute, sorry?
Sorry, I'm sorry, Saleh. I'm sorry, Saleh. Do you hear me? Can you please write your question in the chat, and meanwhile we will ask Eric to ask his question, because we don't hear your question good. Please write in the chat. Eric, please switch on your microphone and ask your question.
Hello, can you hear me? Hello?
Yes.
I can hear you. Go ahead, please. Yeah.
Hi, Omar.
How are you?
Good to see you. Long time. I was wondering about the CN ratio. What do you have a target CN ratio after phase 1 and also after phase 2? What?
Yeah. So, Eric, I now remember you, Eric. Yes, we're in that course. Of course. How you doing? Good.
Yeah, good.
Amazing.
Still here.
Long time. Yeah.
Long
Okay.
time.
So it's an excellent question. It's like a range. So say you start formulating at 28 CN ratio, and then when you reach your end of phase 1, you're in the range of say 20 to 22 CN ratio, and then when you finish your phase 2, you want to be anywhere between 16 and 18. That's usually a good number there. So yeah. So take it like this: 28, 20, 16, 28, 20, 18. That usually works. So that's a good CN ratio. Remember, that's one aspect. That's your chemical physical characteristic, but don't overlook the biological.
Yeah, for sure. And if those values, especially at the end of phase 2, are would you be concerned if that value was much lower than 16?
Not so much. I'd be looking at inspecting the compost, physically, if it's still good, if the structure's still there, if it's holding the right amount of moisture, if it's not greasy, I wouldn't be worried too much about it. I'd look at how it's performing in the phase 2 tunnel. Am I clearing the ammonia? Am I getting a nice growth of beneficials inside the phase 2? What is my spawn run like? Those things I'm more concerned with. But yes, as you said, if you're going below 20 at the end of say phase 1, going into the phase 2, I wouldn't really be terribly concerned about it.
Yeah, good. Well, thank you. Good luck to you, sir.
Thank
Good
you
to
very
see
much.
you.
All the best.
Thank you very much. Thank you. So we have time for the last question. If somebody have one, Saleh, I see didn't write his one. Okay, let me remind you that our offer today is for those who will join online composting course. We'll have half an hour one-to-one session with Omar to discuss his specific situation. Also, if you are owner or manager of compost yard, we will be happy to hear from you. And if you let us to conduct course on your compost yard, it will be really great and appreciated. Thank you very much, Omar, and welcome to our team. I hope you will be able to deliver a lot of benefits to our clients. And thank you to everyone for participation in this webinar. We will send you email with all links and link to recording of this webinar. If you have any questions, reply to those emails. And thank you, Omar.
Thank you very much. Thank you for having me.
Thank you. Bye.
Thank you very much.
Thank you.